We all need water to survive. Now I could survey you guys, but I'm pretty sure you're all going to say that you prefer to be drinking from bottle A. Bottle B, however, comes from a reservoir out at Merredin, and it's suffering from a large-scale cyanobacterial bloom, which you guys may know as blue-green algae. Now, this form of algae is toxic to humans and animals, and it also causes ecological damage. Now, rest assured that in Australia, we wouldn't have to drink from this particular reservoir, but we do reuse the water, we irrigate our kids' schools, and we send it back to the environment. Now, on a more global perspective, it's been found that in areas where people drink from untreated surface water, or where they're serviced by outdoor wastewater treatment plants, there is a higher prevalence of liver cancer, which is thought to be caused by cyanobacterial blooms. Now, in Australia, we have cyanobacterial blooms all the time. There's probably one in Winthrop Pond right now. Sorry. However, when I turn on the tap, I'm still going to be drinking from bottle A. In some areas of the world, you have to drink from bottle B, or you don't drink any water at all. So there's obviously a global concern around cyanobacteria, and that's why my work is looking at a cost-effective, environmentally benign way of removing it and its toxins using hydrogen peroxide. I'm looking at how hydrogen peroxide affects the toxins and the cells, but I'm also looking at how it affects the ecological system that you add it to, and how variables within that system affect the efficiency of removal with hydrogen peroxide. My work's being completed by large-scale field trials out at wastewater treatment plants, which is a very common wastewater treatment technology throughout both the developed and the developing world. So the results should be fairly globally applicable. What we found thus far, very exciting, is that cyanobacteria can be removed within a few hours of addition. And perhaps even more interestingly, the level you need to add it at is too low to harm humans, animals, and plants. So what I'll be doing in the next few months is consolidating all of my work together to prepare a management framework for treating cyanobacterially contaminated wastewater. But it's important that in the future, myself and others look at ways similar to this of treating freshwater drinking sources as well as natural resources. And considering that there are still fellow human beings just like you and I out there drinking from bottle B, I think it's really important that we look at this within both the developed and developing world context. If you aren't yet convinced, I challenge each of you guys to imagine having to drink from bottle B. Thanks.
Particularly enjoyed it with yours, Danny, that you're moving from the local to the global and back to the local and back to the global. I really enjoyed that. I thought it very much allowed us to engage. Thank you.